Good day to all of you. Next we shall discuss on question number 2a. What is binary logic? List out any 4 laws of logic. It is asked for 5 marks. Solution: binary logic deals with binary variables and logical operations. Binary variables can have only 2 discrete values, either logic 0 or logic 1. They can be interpreted as either false or true, or no or yes. See, the logical operations can be AND, or, not, XOR, XNOR, NAND, NOR and buff. Okay. Laws of logic. The first one, commutative law. A logically ANDed with B is equal to B logically ANDed with A. Similarly, A logically ORed with B is equal to B logically ORed with A. This states commutative law. Associative law states that A logically ANDed with B first. The output of that logically ANDed with C is same as B logically ANDed with C. The output of that is logically ANDed with A. So here grouping is changed, but even then the output will be same. Similarly, A logically ORed with B, the output of that logically ORed with C, which is equal to A logically ORed with the output of B logically ORed with C. This is associative law. Distributive law. X ANDed with Y ORed with Z is equal to X ANDed with Y or X ANDed with Z. So distribution of AND over logical OR. It is distributive of AND over OR. Similarly, distributive of OR over AND. X ORed with YZ is equal to X ORed with Y and X ORed with Z. This is distributive law. Inverse law states that X ANDed with Y is equal to identity element where Y is the complement of X. That is, with respect to AND operator, A logically ANDed with A dash is equal to 0. So identity element for AND operation is 0. Any variable ANDed with its complement is equal to identity element, that is 0. Means 1 ANDed with 0 is 0 or 0 ANDed with 1 is 0. Similarly, A ORed with A dash is 1. So 1 is the identity element for logical OR operation. Any variable ORed with complement of itself is equal to 1. Means 1 ORed with 0 is 1 or 0 ORed with 1 is 1. So these are the 4 laws that come in digital logic. So this question 2a carries 5 marks. Next question 2b is for 10 marks. There are 2 sub-questions, sub-question 1 and sub-question 2. So the first one we'll see, f of xyz is equal to sigma of minterm 0, 1, 4, 5, 6 and the don't care conditions being minterms 2, 3, 7. So we'll have to simplify and find the sum of products form expression. So the solution of this first one is, here 3 variables are there, hence 2 raised to 3 squares kmap will have to draw. 1, 2, 3, 4, 5, 6, 7, 8 squares are drawn. And out of 3 variables x, y, z, x is written here, y, z are written here. So for y, z 2 variables, 4 possible combinations 0, 0, 0, 1, 1, 0 and 1, 1 are written here. For x, 2 possible combinations 0 and 1 are written here. Next, in the expression 0, 1, 4, 5, 6 minterms are present. So 0, 1, there in that place in the kmap 1 is filled because 0, 1 minterms are present. This minterm 0 place, minterm 1 place. So 1 are filled. 2 and 3 midterms are not there. Then 4, 5, 6 are there. 4, 5, 6. In midterm 4, midterm 5, midterm 6 place 1 is filled because those midterms are present in the given function. And don't care conditions. So 0, 1, 2. So 2 place don't care condition. 3 also don't care condition. 4, 5, 6, 7 also don't care condition. So don't care conditions in place of 2, 3, 7 the cross mark are filled. So filling of kmap is over. Then we'll have to group ones. So we'll have to find the simplified sum of products expression. Means we'll have to group ones. All 8 ones, if you observe, 1, 2, 3, 4, these are ones. 5 ones are there. Here don't care conditions are there. So to simplify, these don't care conditions are treated as 1. So if these are treated as 1, all 8 places become 1. Hence it's a group of 8 ones. It is a octet, that is the biggest possible. So these all 8 ones covered in 2 rows. Row wise nothing is common. Covered in 4 columns. Column wise is also nothing common. So what all 8 ones means 1 is common. So final expression is f of x, y, z equal to 1. That is the SOP for the given problem. Okay. This is the simplified expression. Next we shall consider the second one. F of w, x, y, z is sigma m of 5, 6, 7, 12, 14, then 15 with don't care conditions 13, 9, 11. So we'll have to fill the kmap. So because 4 variables are there, 2 raised to 4, 16 squares are drawn. Then midterms 5, 6, 7. So 0, 1, 2, 3, 4, 5. This is 5, 6, 7. Because those midterms are present in the given expression, they are written as 1 here. Then 12, 14, 15. So 12, 14, 15 in the sense, this is 8, 9, 10, 11, 12. This is, hence it is written as 1. Then 14, this is 13, this is 14, 15. Both are present, hence 1. Then don't care condition 13, 9, 11. So this is 8, this is 9. So 9 is don't care, cross mark. 10, 11 is don't care, cross mark. So 12, 13 is don't care. So that is present, hence cross mark. In all remaining places, 0 is filled. Whichever midterms are present, there we fill ones. Wherever don't care are present, we fill cross, and remaining places 0. So after filling kmap, we'll have to group ones because we'll have to find the simplified SOP, sum of products expression. So all 16 are not ones. Then anywhere octet also cannot be made a group of 8 ones. Next we'll have to try for quad. If you take quad, so this forms quad, a group of 4 ones, treating this don't care as 1. Next this also forms another quad. So these 4 another quad. So why this group is made? To cover this, because first group these 3 ones are covered, with second group these 2 ones are covered. Then to cover this, one more quad is taken. Okay. Now this quad I have shown, which everybody might try to draw as one group, treating this cross as 1, but that is not needed. Why it is not needed? To cover this 1, when we took this, then we used this cross and it was treated as 1, and this don't care condition was also used for this quad also. But these 2 are not required to cover any of the 1. I have drawn just to show that many might try to draw like this. Okay. Then this is one group, this is second group. So this is first group I have marked, this is second group I have marked. This everybody might take, that is third. This I have taken as fourth one. So with respect to first group, so all these 4 ones, they are covered in this row 1 and 1. So that is Wx we write, that is with respect to first group. All these ones cover in 4 columns. In these columns nothing is common, that is why only row wise what is common that we have written for first group, that is Wx. Similarly, what we have written here second group. So here 4 ones means this row and this row 0 1 1 1. This 1 which corresponds to x, that is common, hence we have written x, which is row wise common for second group. Column wise for second group, these 4 ones fall in these 2 columns 0 1 1 1. So this 1 which corresponds to z, hence z we have written. Xz is the term for second group. Okay. Then for third group, simply I have written, but which has to be neglected. If you write, this will be wrong. So third, many may write row wise. So this W is common. So column wise, this Z is common. WZ it would be common, but this is not needed because these two are not required to cover anything, because this one is already covered in other groups. Okay. So next fourth one, which is named as fourth here, these 4 ones in these 2 rows they are covered 0 1 1 1. So this one and this one is common, which belongs to x, hence x it is. That is for fourth group. So fourth group. So column wise these fall in these 2 columns here. So 1 1 1 0. This 1 is common, which corresponds to y, we have written here. This should be neglected. So then 1 2 this 4, they form the final expression. That is sum of products expression is f of wx yz is equal to wx xz xy. Third one we will not write. Okay. So this is the solution for question number 2b, that is second sub question. So first sub question, second sub question, both together carry 10 marks. That is the solution. It's a typical example where these 2 cross are not required. This cross is utilized for making quad here and this quad also. But these 2 are not required because already all the ones are covered. Hence, though here just I have drawn to show you why such group it should not be used. Okay. I hope you understood this. So in question number 2b, both sub questions 1 and 2 are typical questions and little bit different, unique questions. Okay. And that was the solution. I hope you understood. Next we shall solve question number 2c, which is asked for 5 marks. The question is write a short note on hardware description language, that is HDL. So when the circuit is small, it is feasible to design it manually in paper. So whenever we design any digital circuit, if it is small, we can design in paper only. But if circuit is big and complex, then computer based design is preferred, because it becomes very tedious to design a digital circuit which is very big and complex. To design that in paper, it becomes very tedious. So then computer based design is used. A hardware description language, that is HDL, it's a computer based language that is used to describe the hardware of digital systems in textual form. So digital circuits we can draw. They will be containing logic gates and, or, not, nor, NAND, then XOR, XNOR. So containing all these gates and by an interconnection, so we can draw the logic diagram. But in textual form, if you want to describe, then the language used, which is computer based language, that is hardware description language, is used. Means with that language we can describe a digital circuit in text form. This hardware description language is like C language, but it describes hardware structures and behavior of logic circuits. Logic circuits in the sense digital circuits, where voltage levels happen to be +5 or 0. So it can be used to represent logic diagrams. This HDL, hardware description language, can be used to represent logic diagrams. Then truth tables, Boolean expressions, and complex digital circuits. So HDL can also show the relationship between input signals and output signals of a circuit. Example, an HDL description of an AND gate describes how the logic value of the gate's output is determined by the logic values of its input. Means AND gate, if you describe in HDL, we can show their inputs and outputs by varying the values of inputs and how the output varies. That also can be shown using hardware description language. So example, one statement in HDL language, if you consider, that is Verilog language, A and D, this is the reserved word. This is used to create an AND gate in Verilog program. G1 is the name of the gate, in bracket, then semicolon, within bracket what we write, F. This is output. Compulsorily we have to write the output literal here, comma, then A, comma B. A and B are the inputs to AND gate called G1, and their output is taken into literal F. With this statement in Verilog hardware description language, we create an AND gate having two inputs A and B, their output being F. Then when we vary the values of A and B, the output F will be logical AND of A and B values. So F will be logic 1 only when both A and B are logical 1 here. So this HDL description or statement creates an AND gate in software with the name G1. F is the output, A and B are the inputs. HDL is used to implement logic circuits, study their behavior in software before their actual implementation in hardware. Okay, so instead of implementing in hardware and then seeing to output or observing the behavior, first the implementation of the logic circuit in software, it is done, its behavior for different inputs, the way how the output varies for different values of the input, that is observed. If it is satisfactory only, then that circuit is implemented in hardware. That is the use of HDL language. Okay, that completes the answer for question number 2C carrying 5 marks. So question A for 5 marks, B for 10 marks, C for 5 marks. So question 2abc is for totally 20 marks. That is what is the solution. I hope you understood. Thank you.